Hello, good evening to all. My name is Ganesh Shankar Bhandari and I am a teaching assistant for the NPTEL course Municipal Solid Waste Management taught by Professor Ajay Kalamdar from IIT Guwahati. And I am going to take the live session for this NPTEL lecture for providing some problem solutions. So we will start first. We will start with the revision of the last week lectures. So in the last week, Professor Ajay has taught the transfer and transport system for the municipal solid waste management. So we will talk about the transport for the municipal solid waste management, transport means and methods. So the waste material can be transported in one of the following ways via motor vehicle transport or it can be transported via some other sources. So what is the need of that motor transport vehicles for transportation and what are the factors which needs to be keep in mind while deciding the motor transport vehicle for the transportation of the municipal solid waste from the collection center to the material recycling facility or disposal center or landfill. So the basic factors are the waste must be transported at minimum cost. Okay, so the cost has to be at minimum. Waste must be covered during the whole operation to avoid any dust generation or odor, foul odor or something like that. So it has to be covered during the whole operation. Vehicle must be designed for highway traffic. Then vehicle capacity must be such that the allowable weight limits are not exceeded. Okay, so we have to decide the capacity of the vehicle according to the area. And whatever the amount of the waste is generated in that area, how much amount the residents are generating per on the per day basis or per week basis. So according to that we have to decide the vehicle capacity. Methods used for unloading must be simple and dependable. And then second, first one is motor transport vehicle. Second, we can go with via railroads. So they were used commonly in the past, but nowadays we are not using any railroads to transport the waste. However, we are using the waste which has to be recycled at some facility. Okay, and for reaching that facility, there is no highway transport facility available, but railroad exists. So we have to go with the railroad transportation for the material recycling, for reaching the material recycling facilities for recycling of the waste material. Then coming to the third one, ocean. Via ocean, we can also transport the waste. So they were used to transport waste to processing location and to seaside and ocean disposal sites. But this is not a common practice nowadays. Okay, and it is difficult to use barges and boats during high sea. So that creates a problem and that necessitated the need of some storage location which needs some incurring cost to manage these uh, storage locations, so that add up to the economy of the whole process. So that is not ideal process. Then coming to the fourth one, pneumatic and hydraulic systems. So hydraulic systems are a truck's hydraulic system is engaged when the collection area is sufficiently filled. The hydraulic cylinders moves a compression plate to pack and move the waste into the truck body. Then when the body is full, the truck is driven to a transfer station or landfill to unload and repeat the process. So then coming to the pneumatic system of transport, in pneumatic system of transport, they applied some pressure and via that vacuum, via the generation of that pressure difference, uh, the waste is collected inside the truck. As you can see in the picture, there is a truck here, and they have connected this truck with a pneumatic pressure system, and they are applying some pressure difference with the engine, with the help of engines inside these this truck, and they are generating a suction force for uh, collecting the waste inside this dustbin to that truck. and after the collection they will transport it this waste to the collection site or transport site, or we can say material recycle, or it can be material recycling facilities. So we were talking about the transfer sites, transports. Now we will talk about the transfer stations. So there are some basic factors which needs to be keep in mind while designing the transfer stations. So first is type of transfer operation to be used. Okay. So what type of operation we want to use, we want to perform at that particular transfer station. Okay. So a transfer station facility can work as a waste recovery operation facility, or it can only work as a unloading and loading area for collection vehicles, or it can and it should be incorporate keeping adequate areas available for unloading of collection vehicles. Then second point, storage and throughput capacity requirement. The throughput capacity of a transfer station should be such that the collection vehicles do not have to wait too long to unload. Otherwise, it will affect the whole economy of the process. In the previous lectures, we had talked about the haul time and transfer time, and the total time which is going to take for the collection of the waste. Okay, so that total time uh, is required to decide the number of trips which needs to be done by a particular truck. Okay, so if the taking collection vehicles are taking very long time to unload the waste material at the transfer station, so it will affect the number of trips which needs to be done in a single day, and we have to uh, incorporate more number of trucks in order to collect the wastes in a sufficient manner. Okay. Then storage capacity requirements should be evaluated carefully while planning and designing transfer facilities. A trade-off analysis should be made between capacity of the transfer station and the cost of the transport operation. So we have to keep in mind both equipment and labor components also during the designing of the transfer station. Then equipment and accessory requirements. In a direct load transfer station, usually rubber tired rigs are required to push the waste into the transfer vehicles. So there are some equipments which required in a basic equipments which required in a transfer station to provide to facilitate that unloading of the waste material in a efficient manner. So in a pit storage load transfer station, one or more tractors are required to break up the waste and push them into the loading hopper. Then an overhead clamshell crane is found to be successful for both the purposes. We have to provide some overhead crane to pick up the waste containers from the transport trucks, and like that. Scales should be provided at all medium. So we have to see the weight of the material that has collected by a particular truck, so that we can create an economical process for the efficient collection of the waste material. Facilities for equipment maintenance should also be provided, and so that is the main thing. We have to provide some facility for equipment maintenance at transfer station itself. Then there are some environmental requirements also. So enclosed facilities should have air handling equipment that creates negative pressure within the facility. So there should not be any odor foul creation inside the premises of the transfer station, so that workers can work in a healthy environment. Construction should be fireproof within open loading areas in direct load transfer station. Then sanitation requirements are necessary. There has to be a wastewater pre-treatment plant at transfer station. Then there are some factors regarding health and safety. There should not be scope of dust inhalation by providing mask to all workers, and there has to be overhead water spray facility. and there has to be some air conditioning and dust filtering units also. And the public should not be allowed to discharge waste directly into the pit at larger storage or load transfer stations. So public should not be allowed there, because there are some odor fouls and dust emissions, and they should not be wearing the mask at that time. Okay, so they had to put their waste at required site. Then from that site, the vehicles will collect that waste and they will come to the transfer station. So public should not be allowed to discharge waste directly at transfer station itself. Then there are some factors which needs to be keep in mind while deciding the location of a transfer station. So as it has to be as near as possible to the weighted center of the individual solid waste production area served, and a possible limit is around 10 kilometers from it has to be within the 10-kilometer range, a transfer station, and then within easy access of the major arterial highway routes, as well as near secondary or supplemental means of transportation. There has to be some uh, connectivity with the highway route, so trucks can uh, come and go easily. When there will be minimum public and environmental objection, where construction and operational will be economical, and site selection should be based on the transportation cost, site selection based on the operational constant. And so then coming to the, so we had talked about the transport of the waste material via trucks, via truck transport, via railroads and ocean or water transport or pneumatic or hydraulic systems. Now we will discuss about the separation and processing of the solid waste at transfer station or at recycling facilities. So there are some unit operations for component separation. So first unit operation has itself to be created at the waste generation site itself. Okay, so we have to provide two different bins, like for dry waste, for wet waste, or maybe we can provide a third bin for hazardous waste. So we have to separate the material at the waste generation site itself. So that will make it easy for the collection, and it will also make it easy for the material recycling facilities to recycle the particular waste material. So so there are some unit operations after that, segregation of the waste in dry waste and wet waste. There are some unit operation which needs to be performed before the material recycling operations. So first unit operation is size reduction process. So in a size reduction process, what we are doing, if we are providing some mechanical operation, which is going to reduce the size of the collected materials to obtain a uniform final product. Okay, so why we require this uniform final product? Because if we have to go for the chemical analysis or physical analysis of the waste material, so for that thing we need a uniform final product to do proper sampling. So that's why we go for the size reduction processes, and it also helps in the reducing the storage capacity and shipping cost for the uh, waste material. Then it cannot be defined as a volume reduction process, because shredded paper occupies more space than the parent stock. When we talk about the reduction of the reduction, so if we are talking about the reduction in the size, so what will happen? The surface area, the specific surface area of the product is going to get increased. Okay, so that will take much more volume as compared to the bigger size particles, because the porosity between those particles will be much more uh, as compared to the bigger size particles. So in the size reduction process, we can uh, use different types of shredders like hammer mill or flail mill, or we can use some shear shredder for paper cutting, and we can use some wood chippers for grinding the woody material, or we can use some industrial shredders or for crushing the metallic particle or glass particle, we have to use different types of shredder materials, shredder machines, according to the physical properties of the waste which has to be shredded down. Okay. Then second unit operation is screening. So, a process of separation of mixtures of materials of different sizes into two or more size fraction by means of screen surfaces is known as screening. So, what we will do, we will provide some screen size like 1 mm, 2 mm or 5 mm, whatever the size required in the further processing. Okay, so we will provide the screen size according to the further processing operations size requirement, and we will differentiate the waste material into the different size categories. Okay, or with the help of different size categories, we can also differentiate the different types of waste material. Like if we are talking about the metallic, like if we are talking about the mixture, some mixture of debris and metallic particles. Okay, so if we are going for the shredding process, okay, so what will happen, the debris are brittle in nature, so they are going to reduce in the lower particle sizes, while the metal which is having some ductile nature, it is not going to shred it very easily. Okay, so it is not going to get reduced in the size. Okay, so via screening process, what we can do, we can separate out those debris or inert materials from the metallic particles. Okay, so it will also help us in the differentiation of the different products contained in the municipal solid waste. Then coming to the third operation, after size classification and shredding of the material, we generally go for the density separation. Okay, if we are talking about municipal solid waste, okay, there will be some different types of material inside that municipal solid waste. Like there will be some inert material, there can be some glasses, metallic particles, some paper, some wood, like that. Okay, and those all materials are going to have some different densities. Okay, so like metal will be having a density of around 8 to 15 gram per cc, or paper, if there is some paper, then it is going to have a density of around 0.7 or 0.8 to 1.00 gram per centimeter cube, or if we have some woody material, then it is going to have a density of around 3 to 4 gram per centimeter cube. So there is a difference in the density. So by exploiting that difference in the density, we can classify those materials into different categories for the further processing. So we can use some air classification methods based on the density of the different materials. So we can separate out plastic materials or paper materials or inert debris from the collected waste material. So what we are going to do in a density separation setup, what we are going to do, we are feeding the MSW in feed from some hopper, and then we are providing some counter current air stream. Okay, so material is coming from here, from bottom. We are providing some air stream with some high pressure. So what will happen, the lighter material will go upward due to the high pressure of this air stream, and the heavy fraction will go to downward because air stream will not be able to push it upward due to the high density. So we can separate out light and heavy fractions with the help of the air classification method. Then after that we can go for cyclone separators also. So what with the help of cyclone separators, we can differentiate the lighter materials on the basis of the size. Okay, or we can remove the dirt particles from these lighter materials with the help of the air cyclone separator. Then coming to the second process, we can apply some magnetic separation process also. Uh, the magnetic separation process can help in the classification of the ferrous metals inside the waste stream. Okay, so we all know if there is some ferrous materials like iron or cobalt or nickel or some tin cans of, so we can easily separate them out with the help of some magnetic separations. Okay, what will happen, the magnet will catch the ferrous material which is having some uh, ferrous properties. Okay, so that will be going to stick on the magnets and we can easily separate them out. Then coming to the another one, that is densification process. So after applying the whole other processes like density separation, air classification and screening, so we have separated out different waste streams for the recycling process. Now if there are some waste stream which cannot be recycled further, okay, so in that case we have to go for the landfilling process. Okay, and for landfilling process we need more and more space. So what we will do, we will apply some densification process on the material. Okay, what it will do, it will compact the materials in a lower volume, okay, with the help of some densification compactor, so that if we are going to transport it to some another location, so it will take some lower volume, so we can transport more and more material, okay, in a single transport process. Then these are some facilities for handling, moving and storing MSWs like conveyor belts or movable equipment, front end loaders or forklifts or weighing facilities has to be there, and there are some storage facilities. Then coming to the next one. So next lecture was on separation and processing of the solid waste. Okay, so now we will talk about, we had talked about the classification of waste material into different categories with the help of some classification methods like air classification, density separation, or magnetic separation, or it can be eddy current separation for aluminium, like that aluminium or copper material. So now where these operations are going to happen, that station is known as material recovery facilities. Okay, so at those material recovery facilities we are going to recover the materials from the municipal solid waste into different streams. Like we can separate out metal, we can separate out plastic waste, we can separate out paper waste in different streams, so that it can go to the different recyclers for the further processing of that material. So that can be material recycling facilities can be like it can be like drop off center where you can drop off your waste, like you can drop off your hazardous waste or battery waste or some electronic waste at some drop off center, and you can get some coupons or maybe some money in order to drop off your waste at that point. And there has to be some buyback center. A buyback center enables the resident to purchase clean recyclable materials, providing a clear incentive for use and creating a stable supply. So they will buy back your waste and they will provide you some money or some coupon for purchasing some other things, or you can purchase some recycled material from the center itself after giving them your waste material. So a material recovery facility or multi-reuse facility is a specialized plant that receives, separates and prepares recyclable materials for marketing to end user manufacturers. Okay, so there is some schematic diagram for a material recovery facility. So here the waste is coming by with the help of conveyor belt. It is going into some air sorter. So what this air sorter is doing, it is separating the materials, heavy materials from the low low density materials, like it will separate out heavy metals, cans or heavy plastics from the lower density materials. Then it is going to the paper, or it is going to the another facility. Then we can separate out some glass or paper or glass remains. Then with the help of magnetic separator we are going to separate out the iron and ferrous materials. Then after that we are separating out some stone bottles. Then we are going for the size reduction process with the help of hammer mills. And after hammer milling we are going to sieve it, and with the help of sieve we can again separate out the material in the different categories. Like metal is not going to get reduced in the size, so it will be coming on the as a oversized material, and whatever the material which is going to get reduced in the size, it is going as a undersized material. So after we can create different streams at a material recycling facilities to recover more number of materials from the municipal solid waste. So MRFs have platforms. We had already discussed them in the. So there are some different types of MRF. First is clean MRF. So what will clean MRF do? It receives source separated. Okay. So it will receive source separated. Like we have already separated the waste in dry waste, wet waste, and hazardous waste at the source itself. Okay. So that material is going into the clean MRF, clean material recycling facilities, and there are different types of clean material recycling facilities like single stream, all recycling material are mixed, dual stream, source separated recyclable are delivered in a mixed container stream consisting of glass, ferrous metals, plastic, aluminium, and other non-ferrous metals, or mixed paper stream. So as per specification, materials are sorted, baled, shredded, crushed, compacted, or prepared for shipment to the market. The percentage of residuals, which is known as unrecoverable, recyclable, or non-program materials like debris or inert material, should not exceed 10% by weight of the total delivered stream, and in many cases it can be significantly below 5%. If it is more than that, then the economy of the process will not allow you to run a material recycling facility. Then coming to the second type of MRF facility, which is dirty MRF, which which use mixed waste coming from the source itself. So they are not providing the different waste stream like solid waste or dry waste, wet waste. So there is coming mixed waste from the source itself. It receives mixed solid waste stream to separate recyclable materials through a combination of manual and mechanical sorting. This type of MRF ensures sorting of 100% of the incoming waste streams, leading to a greater number of materials for recovery. This type can recover from 5% to 45% of the incoming materials as recyclables, and remaining is disposed or landfilled. So as compared to the clean MRF, they are going to recycle only 5 to 45% of the material, while in clean MRF, they are going to recycle at least 90% of the material. Rest 10% is going into the landfill. But in case of dirty MRF, around 50% is going into the landfill. So advantage and there are some advantage and disadvantage of the dirty MRF. Some advantages are it increases participation rates for source separated recycling collection system and prepare fuel products and or feedstock for conversion technology. Higher recycling rates compared to curbside or other waste collection systems. Recovery rates higher than clean MRF. Then disadvantages are greater contamination of the recyclables, especially papers. Challenging process since deals with mixed waste stream, like they are dealing with the dry waste and wet waste in the single stream. Installation is very expensive. Operational costs are higher, and this is a labor intensive process. So there are some factors which needs to be keep in mind while designing and planning a process for the material recycling facilities. First is obviously feasibility analysis is if the process is feasible or not, or it is economical or not. Uh, because if there is no economy while recycling the material, so no one will run the plant. Okay, the technical and economic merits are the coordination of the MRF into the overall integrated waste management plan, type of MRF and types of material that the MRF can process, that needs to be keep in mind. Economics, capital and operational cost. A sensitivity analysis of the effects of fluctuation prices is particularly more important, because if we are going to recycle the metallic material or glass material, so the prices are going to fluctuate. Okay, so a sensitivity analysis needs to be done so that we can optimize the process in a more economical way. Ownership and operations such as private, public or combination, or it can be PPP. It can be on a PPP model. Then primary design, which includes development of flow diagram, development of mass balance, development of loading rate of unit operation, development of layout, or physical facilities. Then there are some issues with the issues. There are some issues which needs to be sorted while running a material recycling facilities, like sitting where we are going to plan a material recycling facilities. Okay, at what site? So it has to be on some remote locations, as much buffer as possible. It's like if we are going to need some more area, so we have to have a buffer area as much as possible, so we can store the material while the prices are fluctuating. Okay, so we cannot sell the material in the market. We will wait for the prices to go higher, then we will sell them. Okay, so there has to be some buffer area for the storage at the material recycling facility. Then there are some environmental issues like traffic, noise and dust, odors, emission, vector control and airborne litter, which needs to be keep in mind while designing a material recycling facilities. Then coming to the after the processing of the waste at material recycling facilities, there comes the transformation of that waste. Okay, so recycling of dry waste components needs to be done. Maybe it can be done at material recycling facilities itself, or it can be done via some recyclers. Okay, so what material recycling facility will do, they will classify the material into different categories and they will sell them to the different waste recyclers. Okay, like they can sell it to the metal recyclers, or they can sell it to the plastic recyclers or glass recyclers. So they can recycling those materials to create the new products. So what is recycling? Solid waste management rules SWN 2016 defines recycling as the process of transforming segregated solid waste into a new product or a raw material for producing new products. Okay, so what are the advantages of recycling? It can reduces the waste volume. It can save the cost in collection, transportation, and disposals. Uh, it will provide some longer lifespan for landfills, because landfills have a definite defined area. Okay, so if we are going to recycle more and more materials, like if we are going to recycle at least 50% materials from the municipal solid waste collected, so only 50% is going into the landfills. Okay, so life of that landfills is going to get increased. Then reduce environmental management efforts, and it will also provide sustainability regarding if you are going to recycle the metal or plastic waste or paper waste. So it will provide the better economy while creating the new materials. Okay, it will help in that process also. For the economy, it will reduce the reduction of imports of raw materials or fertilizers, or it will also create livelihood opportunities for the recyclers. For environment, it can be used as a sustainable use of resources and reduce waste volume and hence reduce land requirement for disposal. So coming to the plastic recycling. So plastic recycling is the process of recovering different types of plastic materials. Like there are different types of plastic material like polyethylene, composite plastic materials, or PVC plastic materials. So there are different types of plastic materials. So we have to recycle them separately. Okay, an item made of plastic or out of plastic is recycled into a different product which usually cannot be recycled again. These are 7 different types of polymer groups which are given numerical coding from 1 to 7. This there is LDPE, low density polyethylene, polypropylene, polystyrene, or miscellaneous types of plastic, and there are 3 more type of plastic material. Not all 7 group of plastics are recyclable. So these all cannot be recycled. So stages in plastic recycling processes are: first we have to segregate the plastic materials into the different categories. Segregation of different plastic item is done by their resin content and colors. Like we have to separate them out according to these 7 categories, because some of them cannot be recycled again, but some of them can be recycled again and again. So segregation can be manual or mechanical, or contaminants are eliminated. Then we have to wash those plastic materials. Most containers and packages have labels, adhesive, or even food residue that must be removed before the recycling process. Otherwise, it will create contaminations during the recycling process. Then we have to shred those materials. Shredding is granulating the plastic waste into small particles so that it can facilitate the further processing for the recycling of the plastic material. These increases the surface area of the plastic, making it easier to process, reshape and transport if needed. Then additional step to remove any non-plastic waste that might have escaped the previous stop processing. Then identification and classification of plastic. There are different types of tests to determine the quality and class after shredding. One is density test, which is done by the floating the particles in a large tank of water. So what will happen? The particles which is lighter than the water, that will float in the tank, and the denser will get sink. So the particles which is going to float on the surface of the water, that are good for the recycling process, while which has sinked, which are reported to the sink material. So that we have classified in two different categories. That sink material has to go for the different recycling processes, or it contains, or maybe it is containing some residue materials inside those plastic materials, so it is going to sink inside that water due to heavy density. Then air classification test determines how thick or thin a particle is. Dense by dropping the particles into a small wind tunnel. The smaller pieces will fly higher up the tunnel and bigger ones will remain lower, so we can shred them further. Two other additional features plastic which are commonly tested are melting point and color, determined by collecting and analyzing sample from each batch of plastic particles. Then extruding and compounding. Small particles are smashed and melted together into plastic pellets, and these pellets can be used as a production material for for producing other plastic products. So then second one is metal recycling. So metals are valuable materials that can be recycled repeatedly without degrading their properties. And metal, mainly MSW will contain steel material, then aluminium cans, or it can rarely contains copper materials or something else. Majorly it will contain steel or aluminium cans. Okay, so these two metals can be easily recycled via the recyclers. So it is a rather easy process than the recycling of the plastics. So we can directly melt them and we can produce new materials. And then there are some stages in material recycling process, like we have to segregate the metals into different categories from mixed scrap metals. Like we have to segregate them, if there is a mixed metal stream from aluminium, copper or ferrous materials, then we can separate them out with the help of some magnetic separation or eddy current separators in the aluminium and steel, because we cannot melt them together. Otherwise we are going to lose the precious metal contents during the recycling processes. Then we have to shred them in the smaller pieces. After shredding, we will go for the melting process in some large furnaces, and after melting we are going to solidify them in the form of some ingot or something like that, ingot. And from that ingot we will go for the from those ingots or metal bars, we will go for the uh, further processing or further making of the different products. Then coming to the glass recycling process. So in this recycling process, we will go for the recycling of the glass. So as we had already discussed in the plastic recycling or metal recycling process, first we have to segregate them in different categories. Like there we can see three different types of glass materials. One is clear, then green and brown. So these these has to be separated out in the different categories according to their colors. Then only we can recycle the glass material. So there are some stages in glass recycling process, like segregation. We have to segregate them according to the different categories of glass. Then we will go for glass breaking. Then we will go for trommel. Like we will go for screening process, so that we can separate out the glass from the other materials if there are some impurities which is coming with those glass bottles, like caps or holders or some metallic materials with the glass bottles. So what will happen during the crushing process, the glass will going to break into the smaller pieces, but the metallic or other particles is not going to break into the smaller pieces. So with the help of the screening process, we can separate them out. After that, we can go with the fluidized bed dryer, and then we will go for primary rotary screen for dried and clean glasses, screen to cull out specific sizes. Then we will go for pulverizer to produce the glass powder, and after producing the glass powder, we will go for the melting operations to create new glass materials. Then coming to the cardboard recycling process. So there are some stages in cardboard recycling processes also. First one is sorting. So we can sort them out according to the two different types, like box board or corrugated boxes. Then we will go for shredding and uh, pulping of the cardboard material. And after pulping, we will go for filtering, terminal and conterminal removal. Then we will go for de-inking and cleaning process of that pulp material. After the de-inking and cleaning of that pulp material, we will go for making of new cardboard material to facilitate the uh, further processing of that cardboard material. Then coming to the paper recycling. In paper recycling also, we have to segregate them out, and then we will go for shredding and de-inking and bleaching process. Then we will go for drying and pressurizing process to recycle the paper waste. So these were the lectures which were taught during the last week in the municipal solid waste management process. Now we will discuss some question and answer based on the last week lectures. So the first question is, what is the requirement for setting up an economic transfer station? So we had discussed some factors while stabilizing while picking up a location for establishing a transfer station. So what is the main requirements for transfer equation? So answer is, we had discussed that it has to be around 10 km far from the city boundary, and smaller vehicles are used for the transport facilities, because we cannot transport via railroads, or we can not transport uh, via some other sources like water source or something like that, or we cannot transport via large dump pistols at disposal site. We have to go with the smaller type of vehicles from curbside collections or haul type container systems. So it has to be at least 10 km far away from the city boundary, by keeping in mind some environmental factors and some health hazards of the people residing in the city. So the answer is A. So next question is, if the quantity of waste generated is low, waste separation can be done at material recovery facility, separation at the source itself, after dumping in the landfill, or none of these. So if we are talking about the low quantity of the waste, okay, so we cannot go for material recovery facility with the economical processing. Okay, so it will be wiser to separate out that waste at the source itself. Okay, that will help in the further processing of that waste. So if the quantity of waste generated is low, so it is better to separate them out at the source itself. And next question, which of the following does not require size reduction of waste? So why we do the size reduction of waste? To reduce the storing capacity, to reduce shipping cost, to get a uniform product, or to reduce volume, which is not a factor involved during the size reduction of waste. Why we do size reduction of waste? So why while doing the size reduction of the waste, we are definitely going to reduce the storage. Okay, because if the size is reduced, so it will take some lower, so we can then it will also reduce some shipping cost. Then we can get a uniform product and to reduce volume. So that will not going to happen during the size reduction processes that we had already discussed, because during the size reduction process what will happen, they will convert it into the smaller size particles, and due to that smaller size particles, what will happen if we are not going to compact them together, okay, that will increase the volume of the particles, okay, until unless we are going to compact them. So if we are going to compact them, what will happen, it will reduce the storage, it will reduce the shipping cost, and it will provide us a uniform product without compaction process. And fourth one, screening is the process of separation of waste of different densities, separation of waste of different volume, separation of waste of different sizes, and separation of waste of different mass. So screening was the process which we had defined for the separation of waste into the different sizes. Okay, for separation of waste into different densities, we had considered the density classifiers like air classification or cyclone systems for the different density separations, or we can go with the water float sink method for separating them out into the different densities. Then on the basis of different volumes, we can go with the classification processes also. Then separation of waste of different sizes. In that case, we have to go with the screening process, because we can provide the different size screenings like 10 mm or 1 inch or 1 mm, depending on the requirement of the further processing. Okay, so we can separate them out on the basis of different sizes with the help of screening. And separation of waste of different mass can be done via the density separation processes itself. Then next question, which type of waste separator is used for the separation of light material from heavy material based on weight? Screening, density separator, magnetic separator, or none of these? So we had already discussed uh, that screening process is for the classification of the municipal solid waste into the different sizes. Okay. So screening is for the size separation, then density separation. It is for the separation of particles from lighter one to heavier one. Okay. So based on the density separation process, we can separate out particles into two different streams. One is lighter fraction, second one is heavier fraction. Okay. So the answer is density separators. And based on the magnetic separators, we can separate out the waste into two different categories, like one is non-ferrous waste and second one is ferrous waste, because ferrous waste is always going to provide you some magnetic properties, so you can easily calculate that properties for differentiating iron or tin particles from the other waste categories on the basis of magnetic separation. Then next one is, what is the technique used to store and transport waste cheaply? Shredding, conveyors, hydraulic and pneumatic system, or densification. So when we are talking about the transportation of waste in a very efficient manner, okay, so what we will do, if we are going to take a waste of around 100 meter cube, okay, let's say 100 meter, we are collecting of waste volume of around 100 meter cube. So if we are going to transport that waste like itself in the volume of 100 meter cube itself, okay, so if we have a truck capacity of around 50 meter cube, we have a truck which have a capacity of 50 meter cube, okay, so we require at least two trucks for transporting the waste material which has a volume of around 100 meter cube. However, if we are going to compact that waste up to 50%, okay, it's like we are going to compact that 100 meter cube waste into 50 meter cube volume with the help of some compactors. Okay, so what will happen? Now we are going to require only one truck for the transportation of the same quantity of the waste. Okay, so we are reducing the overall transportation cost by the densification, or we can say compaction of the waste. Okay, so via densification of the waste, we can transport it in a very cheap manner, or we can store much more material in a lower volume. Okay, via shredding, we are going to increase the we can say we are going to reduce the size of the material, and after reducing the size of the material, what will happen? It will increase the volume of the material. Okay, so it is not going to help. So it is not going to help during the densification of the process, during the densification of the municipal solid waste. Then conveyors that are only for transporting the material from one place to another in a material recycling facility. Then hydraulic and pneumatic systems are for transferring the waste from the dustbin to the pneumatic and hydraulic system containing trucks, okay, which are used for the transportation of material solid waste from one place to the another place. Then coming to the next question, what is the requirement of a waste drop off center? The waste generator is not responsible for carrying the waste to collection station. The waste producer has to carry the waste to the collection center. The waste producer can purchase the recyclable material from waste drop off center, or none of these. So anyone wants to answer? So we had discussed that waste drop off centers are the centers where the waste producer has to carry their own has to carry their waste, and they will drop it at that collection center, and maybe after dropping off that waste material, they can get some maybe some money or some coupons for purchasing the different things. Okay, for purchase of they can use those coupons to purchase the new product or recycled products. So okay, so the requirement of a waste drop off center is for the waste producer has to carry the waste to the collection center. Okay, and the third one is the waste producer can purchase a recyclable material. So the waste producer cannot purchase a recyclable material from a waste drop off center, but they can purchase a recyclable material. Maybe they can purchase some recyclable material from a material recycling facility, or they can purchase the recyclable material from some other places. Okay, but they cannot purchase it from a drop off center. They can only get some economic benefits while dropping the waste at the drop off center. So next question, waste such as HDPE or PET are usually separated by. So HDPE and PET are both the plastic materials. Okay, these are different category of the plastic wastes. So how we can separate them out? So for plastic material, what we can what properties we can exploit, that is the density based separation. Okay, some of the plastic material can be heavier, and some of the plastic types can be in lighter on the weight. Okay, so with the help of some maybe air classification system or some density blower, we can separate out these plastic materials based on their physical properties. Okay, and conveyor belts are only for the transportation of the materials, so this is not true. And eddy current separators are the uh, physical separators, okay, which generally used for the separation of the aluminum and copper materials from the other type of metallic materials. Okay, so that cannot be used for the separation of the plastic materials. So we can generally use density blower, or maybe we can use some air classification system to separate out HDPE or PET based on their density differences. So coming to next question, which among the following are non-recyclable plastics? So we had discussed about 7 different types of plastic materials, and we had already discussed that some of them cannot be recycled back. Okay, or maybe some of them can be recycled again and again, or some of them can be recycled only 1 or 2 times, or some of them cannot be recycled at all. So there are 4 types of plastic materials: low density polyethylene, polypropylene, composite plastics, and polystyrene. So which among them cannot be recycled again? So first we will discuss what are the types of these plastics. So this is the types of low density polyethylene. Okay. So these types of plastics are generally considered for keeping the chemical materials because they have very uh, inert nature as compared to other type of plastics. So they are not going to react with the chemical materials or some or any type of organic materials. Okay, they are inert in nature, and they can be easily recycled back again and again. Okay, so these are low density polyethylene plastics, and these types of plastics are generally used for making PET bottles also. Okay, polyethylene bottles, we generally consider them, so they can be recycled again and again. Then coming to the second one, polypropylene. So these are these types of plastics are basically hard in nature. Okay, and these are heavier than low density polyethylene plastics if we talk about the physical properties. Okay, and they can be recycled at least 1 or 2 times. They can be recycled at least 1 or 2 times, and these type of plastic have a has a property which can these types of plastic can sustain a temperature up to 90 or 100 degrees Celsius. Okay, usually you can see them as a lid on your if you have seen Milton lunch box. Okay, so the lid of that lunch box is generally made up of that polypropylene plastics. Okay, because they can sustain a temperature up to 90 or 100 degrees Celsius. So they can be uh, used as a lid material for the lunch boxes. Then coming to the third one, composite plastics. So these are the types of, as name suggests, these are composite materials. Okay, and if when we are talking about composite plastics, So these types of plastics are generally created with the mixture of some plastics and some woody materials. Okay, so in present we can see some doors. Okay, okay, there are some in past we were using the door, we were making the door with the help of woods. Okay, or some mica or plywood. Okay, nowadays we can see the doors are uh, made up of these composite plastic materials which are a mixture of wood and plastics, and they have a better strength as compared to the wood doors, and they have better inert properties, like they are not going to react with uh, water or moisture, and they are not going to swell up like your wood material. Okay, so these are composite plastic materials. Then coming to the fourth one, polystyrene. So all you have seen thermocol material. Okay, and in recent days we have seen thermocol uh, cups, thermocol plates, thermocol bottles. Okay, so these are all made up of the polystyrene materials, and these polystyrene materials can be recycled at least 1 or 2 times. So in these four categories, only this is the one composite plastic material which cannot be recycled back. Okay, once you are going to mix up the plastic materials with some woody material or maybe some metallic material. Okay, so after that you will not be able to recycle that material again. Okay, so among these four types of plastic, the composite plastic is the one which cannot be recycled again. Rest of the three plastics can be recycled 1 or 2 times at least, based on their properties. Then coming to the next question, what are the stages of the glass recycling processes? So we had discussed during the glass recycling processes. First, we have to segregate the glass according to different categories. Okay, like we can say uh, there are some glass which is opaque in nature. It can be having some color like green color, or we can say there can be brown bottles. Okay, so you know generally white color or transparent glass bottles are used for keeping the used as a water bottles. Okay, and these brown bottles are generally used for keeping the chemical materials which has to be kept away from the sunlight. Okay, so these brown bottles have a unique property. They cannot allow the sunlight to be pass from that material to inside the bottle, while the opaque one, which has transparent color, the sunlight can easily pass from that bottle. Okay, so we have to separate out these glass bottles according to the different categories, like on their color, because different types of bottles has to be treated in a different process, because they contain some different chemicals inside them. So it will be easier for the recyclers to recycle them again and again. So first one is segregation. Then after segregation process, we have to break that glass material. We have to break the glass bottles into smaller pieces. Then after breaking the glass material, we have to go for the trommel or screening process. So what will happen? There will be some bottles which will containing some caps or lids on them. So during that glass breaking process, what will happen? If the glass bottle contains some cap of plastic material or maybe some wood material, wood cork, or it is if it is containing some metal cork or metal lid on that bottle. So what will happen during that breaking process? the glass is going to break, but your metal is not going to break into smaller pieces. So with the help of trommel screen, what will happen? This will facilitate the classification of the glass material and the wood cork material or maybe plastic material or metals from that glass material. Okay. So first one segregation, then glass breaking, then trommel, and after that trommel process we will go for fluidized bed dryer. Okay, so during the trommel, if we are going with the wet screening processes, okay, or we have to wash that glass material, then we will go for fluidized bed dryer. Then after going with the fluidized bed dryer, we will go for primary rotary screen, which will facilitate the separation of bigger size particles from the smaller size one. Okay, then after separating the particles into smaller and bigger pieces, we will go for pulverizing process, and after pulverizing process we will go for secondary rotary screen size, because uh, there are chances that pulverizers will never process with a 100% efficiency. It can process the material with a efficiency of around not more than 70 to 80%. So there will be around 30% material which needs pulverizing again. Okay, so in order to pulverize that 30% material again in pulverizer in smaller sizes, what we need to do, we have to separate that material out with the help of secondary screen size. So in that secondary rotary screen size, what we will do, there will be some underflow which can directly go for the recycling process, and there will be some overflow which will be containing that 30% or 40 material which had not pulverized up to the required size. So we have to pulverize that size back with the help of the pulverizer, and then again we will go for the secondary rotary screen. Okay, so the stages in the glass recycling processes are segregation, then glass breaking, trommel, fluidized bed dryer, primary rotary screen, pulverizer, secondary rotor screen size, and then classifier. So the answer is C. So this is for today. If anyone wants to ask any question, you can ask, or we can finish this meeting. Anyone wants to ask something? Okay, thank you. So no one have any queries, so we will finish this meeting. Okay, thank you for joining for today's live session.